नमस्कार दोस्तों। आज हम लोग स्टार्ट करने वाले हैं पार्ट 2 ऑफ केमिकल रिएक्शन एंड इक्वेशन। माय नेम इज मेघा एंड आई एम योर बुक रीडर। लेट्स स्टार्ट। 1.1 Chemical Equation. Activity 1.1 can be described as when a magnesium ribbon is burned in oxygen, it gets converted to the magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen reactant gives magnesium oxide product. The substance that undergoes chemical change in the reaction 1.1, magnesium and oxygen are the reactant. The new substance is magnesium oxide formed during the reaction as a product. A word equation shows change of reactant to products through an arrow placed between them. The reactant are written on the left hand side LHS with a plus sign between them. Similarly, products are written on the right hand side RHS with the plus sign between them. The arrowhead points towards the product and shows the direction of the reaction. Page number 3, 1.1.1 Writing a chemical equation. Is there any other shorter way for representing chemical equation? Chemical equation can be made more concise and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and the magnesium oxide, the above words equation can be written as Mg plus O2 gives MgO. Compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on the both sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. 1.1.2 Balanced chemical equations. Recall the law of conservation of mass that you studied in class 9th. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the element present in the product of the chemical reaction has to be equal to the total mass of the element present in the reactant. In the other words, the number of atoms of each element remain the same. Before and after a chemical reaction, hence, we need to balance a skeletal chemical equation. Is the chemical equation 1.2 balanced? Let us learn about balancing a chemical equation step by step. The word equation for activity 1.3 may be represented as zinc plus sulfuric acid gives zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical equation. Zn plus H2SO4 gives ZnSO4 plus H2. Let us examine the number of atoms of different element on both sides of the arrow. Element, number of atom in a reactant LHS and number of atom in product RHS. Zn zinc, 1 atom in the reactant, 1 atom in the product. H hydrogen, 2 atoms in the reactant, 2 atoms in the product. S sulfur, 1 atom in the reactant, 1 atom in the product. O oxygen, 4 atom in the reactant, 4 atom in the product. As the number of atoms of each element is the same on both sides of the arrow, equation 1.3 is a balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2O gives Fe3O4 plus H2. Step 1. Page number 4. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the chemical equation. Fe iron plus H2O water gives Fe3O4 ferrous oxide plus hydrogen H2. Step 2. List the number of atoms of different elements present in the unbalanced equation. 1.5. Elements. Number of atoms in the reactant, number of atoms in the product. Fe, iron. 1 atom in the reactant, 3 atoms in the product. H, hydrogen. 2 atoms in the reactant, 2 atoms in the product. O, oxygen. 1 atom in the reactant, 4 atoms in the product. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using this criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atom, initially atom of oxygen in reactant 1 in a what H2O, in a product 4 in Fe3O4. So to balance 1 multiplied by 4 in a product 4. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compounds or elements involved in the reaction. For example, to balance oxygen atom, we can put coefficient 4 as a 4H2O and not H2O4 or H2O bracket complete 4. Now the partially balanced equation becomes Fe plus 4H2O gives Fe3O4 plus H2. Partially balanced equation 1.6. Step 4. Fe and hydrogen atoms are still not balanced. Pick any of this element to proceed further. Let us balance hydrogen atom in the partially balanced equation. To equalize the number of hydrogen atoms, H atoms make the numbers of molecules of hydrogen as a 4 on the RHS. Atom of hydrogen in reactant in product. Atom of hydrogen initial in reactant 8 in a 4H2O in a product 2 in H2. To balance in a reactant 8 in a product 2 multiplied by 4. The equation would be Fe plus 4H2O gives Fe3O4 plus 4H2. Partially balanced equation 1.7. Page number 5. Step number 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. Atom of ions in reactant in product. Initially, atom of ions in reactant 1 in Fe. In product 3 in Fe3O4. To balance 1 multiplied by 3 in reactant, 3 in product. To equalize Fe, we take 3 atoms of Fe on the LHS. 3Fe plus 4H2O gives Fe3O4 plus 4H2, 1.8. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Balanced equation 1.9. The number of atoms of elements on both sides of equation 1.9 are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method. As we make trial to balance the equation by using the smallest whole number coefficient. Step 7. Writing a symbol of physical states. Carefully examine the above balanced equation 1.9. Does this equation tells us anything about the physical state of each reactant and product? No. Information has been given in this equation about their physical state. To make a chemical equation for more informative, the physical states of reactant and the product are mentioned along with their chemical formulae. The gaseous, liquid, aqueous and the solid state of reactant and the product are represented by the notation G, L, aqua and S respectively. The word aqueous AQE is written if the reactant or the product is present as a solution in water. The balanced equation 1.9 become 3Fe bracket S plus 4H2O bracket G gives Fe3O4 bracket S plus 4H2 bracket G 1.10. Note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. Usually, physical states are not included in a chemical equation unless it is necessary to specify them. तो यहाँ पे हमारा बैलेंसिंग ऑफ इक्वेशन, writing a symbol of physical state has completed. Next class we will continue with the another examples of balancing equation. Thank you.